science relies on trust. It couldn't possibly proceed unless scientists working in one area were able to trust the results of scientists working in another area. Even the most accomplished scientists today rely on the results of many other scientists to conduct their research. For example, theoretical physicists develop their theories based on data collected by experimental physicists, but they may have no idea how the experiment itself works. They have to trust that the experimentalists are getting it right. Science is a huge collaborative endeavor. In order to do research in any area of science, the reliability of other research areas must be taken for granted. Science as an institution has standards for trustworthiness both with respect to individual scientists and with respect to scientific claims. In this video, we'll talk about the related ideas of testimony as a source of knowledge and scientific expertise. We'll discuss how to judge a scientist's expertise and the institutional practices of science that ensure its reliability. By seeing why it is that scientists trust each other, we can learn something about how we should view scientific expertise and why we should trust the testimony of scientists about their research. What does it mean to be a scientific expert? Experts in general are people who know a lot within a specific area, more than lay people. In science, expertise is developed over time by studying and participating in research in a field. The most obvious sign of expertise in science is an advanced degree in that discipline. However, it is possible for a scientist to develop expertise in areas that are different from the one in which they got their PhD. For example, it will not be at all unusual for a scientist with a PhD in biology to also have significant expertise in some other field like statistics or chemistry. While the degree is an important signifier of expertise, it is not the full story. The other important mark of expertise in an area is a publication record. That scientist with a PhD in biology, but expertise in statistics as well, would likely have published papers that demonstrate their expertise in statistics. And on the other hand, someone with a PhD in a field might not take the steps needed to maintain their expertise. So, a combination of an advanced degree in a scientific discipline and a publication record in related areas are the major signs that someone is an expert in a field. Now, why should we, lay people, or other scientists for that matter, trust the claims of science? In order for a scientific claim to be accepted, it usually needs to pass the standard of peer review. A scientific article that has been submitted to a journal for publication is sent out for review to other experts in the field. They assess the quality of the research and the claims made by the paper's authors. Only if these meet the relevant standards will the paper be published, and thereby be accepted as part of the scientific record of that field. Importantly, the reviewers do not need to agree with the conclusions of the paper they are reviewing. They just need to assess it as being an original and high-quality contribution to the ongoing discussion in that area. A paper that has passed the process of peer review and has been published can be reliably viewed as being of high quality. So, peer review and publication serve as a proxy for researchers without the relevant expertise to assess the claims made by a paper as being of high scholarly quality. This is related to the idea of testimony as a source of knowledge. Scientists regularly rely on the claims of researchers with related expertise to get their own research projects off the ground. But how can they be sure that the testimony of those other researchers is trustworthy? Claims that have been peer-reviewed are ones that can be viewed as more reliable. Science, as an institution, has ways of recognizing expertise and relies on expert opinion through the process of peer review to validate claims made in the scientific articles. These two components are a robust process for generating trustworthy claims. This is what researchers in other areas who do not have the relevant expertise to judge for themselves rely on for accepting the testimony of other scientists. However, there are potential problems. Most importantly, this system assumes that everyone is operating in good faith and has the same goal of advancing scientific knowledge. But some bad actors who have other motivations, for instance, advancing their own careers, can exploit the system to get articles published that include academic misconduct. For example, if I were to make up a data set and then argue that it supports my hypothesis, that paper might get through peer review and then get published because peer reviewers would assume that I really did the experiment that gave me the data. It's not their job to investigate whether or not I'm lying, only whether or not my analysis of the data is good and supports the claims I make. In cases like this, when it comes to light that some research has been faked, the journal in which the article was published will retract the paper, meaning they will remove it from the scientific record. This is another way in which science constantly improves our understanding of a topic. New research is subject to expert peer review, and any research that is discovered to rely on malfeasance and therefore does not meet the standards of science will be retracted. In fact, this is taken so seriously that even less extreme versions of these problems can be enough to end a scientist's career for good. So why should we trust what scientists say? A mature scientific discipline will have many experts who may disagree significantly about what they believe, but they will all agree on what kinds of claims are legitimate, what kinds of methods are reliable for producing knowledge in their field, and what the major points of agreement and disagreement are. They participate in a process where every new article is subject to peer review, and they are always willing to abandon any claim that has later been shown to be wrong or is the result of error or misconduct. So the points on which they agree, the points on which there is significant consensus can be trusted as the best knowledge we currently have from that discipline. This is how expertise leads to trustworthy testimony in science.